In this video we will explore what the air we breathe is made from, and whether it has always been like it is now. Our air is a mixture of gaseous elements and compounds. In dry air, the most abundant gas at 78% is the element nitrogen, and the second most abundant, at 21%, is the element oxygen. Together these make up 99% of our air. The remaining 1% contains mostly the element argon. Carbon dioxide is present in very small quantities, 0.04%, along with tiny quantities of lots of other gases. Nitrogen and argon are inert, which means they're unreactive and don't do much in the atmosphere, but oxygen is essential for living animals to respire, and carbon dioxide, even though it's only there in tiny quantities, is responsible for keeping the temperature on Earth within the limits where animals can survive. We don't know exactly what the Earth's original atmosphere was like, but we do know that it wasn't like it is now. It is impossible to measure what the atmosphere was like millions of years ago, but we can certainly analyse air from thousands of years ago because it gets trapped as bubbles in ice. The deeper into the ice we drill, the older the air bubbles get. To understand the atmosphere further back in time, scientists have to use models that take into account what has caused the atmosphere to change over time. We believe that the first atmosphere was made by volcanoes releasing gases such as carbon dioxide and water vapour. There was little or no oxygen. The early atmosphere, like the early Earth, was very hot, and the water was present as a gas, not as water droplets. As the Earth cooled, eventually the atmosphere cooled below 100 degrees C, and as this happened, the water vapour condensed and formed droplets of liquid water. It rained for the very first time, and lakes, rivers and seas began to form. One of the ways in which scientists can see whether their models make sense is to compare our atmosphere to that on nearby planets. Mars and Venus are our nearest neighbours, and their atmospheres show what ours might have been like originally, and how it regulated the temperature of the Earth.
Mars is a frozen wasteland with an average temperature of -60 degrees. That's because its atmosphere doesn't have enough carbon dioxide to keep it warm. At the other extreme, the temperature on the surface of Venus is hot enough to melt lead. Not simply because it's a bit closer to the Sun, but because Venus has an atmosphere with thousands of times more carbon dioxide than Earth. The early Earth was much more volcanic than it is today because its core was so much hotter. This provided enough carbon dioxide to compensate for the weak sun. It was volcanoes that prevented the young Earth from freezing over.
Unlike the atmosphere of Mars or Venus, the Earth's atmosphere was changed by the existence on Earth of living organisms. The first living organisms were simple plant-like bacteria that were capable of photosynthesis. This process used carbon dioxide from the atmosphere to produce food for the organisms and released oxygen as a waste product into the atmosphere.
Might not look like it. These are the most successful life forms on the planet. You know, us humans have been around for a few million years. The dinosaurs came and went in 200 million years. These stromatolites have been around for 3,500 million years. That's 3/4 of the age of the planet. And yet, when they first evolved more than 3 billion years ago, these simple life forms began the most important transformation the planet has ever seen. These stromatolites are special because they did something that was quite extraordinary. As they took in the sunlight and photosynthesized, They broke down the chemical bonds in water, releasing something that would completely change the planet. They released oxygen. Stromatolites were the first life to photosynthesize and release oxygen into our world. This led to one of the most profound changes in the history of the Earth. Ultimately, the planet would have an atmosphere rich in oxygen. About 600 million years ago, it ended the long reign of the stromatolites and caused a revolution in the development of life. This is because oxygen is highly reactive and can support far more energetic forms of life than bacteria. Blessed with an oxygen-rich atmosphere, Earth became home to an extraordinary diversity of complex life. And ultimately, to us.
As a result of photosynthesis and carbon dioxide dissolving in the water of the oceans, carbon dioxide levels decreased over time to a very low level. Oxygen levels increased as plants and algae released it during photosynthesis, and nitrogen levels also increased. The early atmosphere contained ammonia, but as oxygen levels increased, ammonia and oxygen reacted together to form nitrogen and water. Some types of bacteria also released nitrogen into the atmosphere as they fed and grew. Eventually there was sufficient oxygen in the air to support animals that respire by taking in oxygen and releasing carbon dioxide. In this way, plant life and animal life balanced the levels of oxygen and carbon dioxide, keeping them from further change. It is only in the last few hundred years since the Industrial Revolution that the atmosphere has begun to change again, but this time the change is man-made. We have been burning fuels for transport and industry at a rate which has significantly increased the levels of carbon dioxide in the atmosphere, leading to global warming and climate change. Our activity has also led to contamination of the atmosphere with other waste products from industry which cause acid rain and some health problems.